Okay, explain the origin of the buoyancy force on the air bubble. Two things you want to talk about. You want to talk about what happens to the pressure as the depth increases. Okay, so as you go down in this fluid, what happens to the pressure? Okay, and then talk about the pressure at the bottom and the pressure at the top. Okay, compare the pressure at the bottom to the pressure at the top. This is why there is a buoyant force, because there's a different pressure at the bottom of something than there is to the top, right? And then B says that with reference to the ratio of the weight to the buoyant force, well, remember the weight of an object is just the density times the volume times g, right? Well, the volume is the same, g is the same, right? So the ratio of the weight to the weight is just the ratio of the densities, right? Right? Well, these cancel out, so it just ends up being the ratio of the densities. So talk about that ratio of the densities. If it's a very small ratio, that is, air is much smaller than the liquid, then you could neglect that, right? Okay. Now, calculating the terminal speed, you're going to say that the buoyant force is equal to the Stokes force. Now, what's interesting here, normally it's like, the force of gravity acting down, right? But this thing is floating, so actually the Stokes force will be down, right? That FD is going to be down, and the buoyant force will be up, right? And they will be equal at terminal speed, right? They'll equal each other. Remember your Stokes force is, what is it, 6 pi, the viscosity R times V. Let me look at my data packet. Let's make sure I'm not lying to you. Pretty sure that's what it is. And these are in the back of the data packet. There it is. Yeah, 6 pi, the viscosity times R times V, right? And then the buoyant force, so that's your, right? And then the buoyant force is going to be, well, actually the net buoyant force, right, will be rho 1 minus rho 2 times the volume of the object times g, right? Now they're telling us that we can neglect the 1.2, so this would be 1200 would be this guy, and then the 1.2 would be this guy, but I didn't do that. Actually, I did, and it doesn't matter. You could do it with it. You could do it without. They are correct, right? Your volume is going to be, what, 4/3 pi r to the third, and your r is equal to, be careful there, right? It's 0.25 millimeters, so 0.25 times 10 to the minus third meters, okay? Happy hunting.